So one thing that pops up when we're dealing with exponentials and such is evaluating limits involving exponentials. So we're going to look at a couple of theorems here that will help us do that. Okay, and to start with, I've got this limit as x approaches infinity of the quantity 1 plus 1 over x raised to the x. Now, before we look at what that limit is equal to, I want to look at it as a function and evaluate numerically and try and estimate what we get as x approaches infinity. So I've got the quantity 1 plus 1 over x all raised to the x plugged into my calculator for y1, and I'm going to evaluate that function at some large number. So I'm just going to start with 4 nines here. All right, I get 2.718. Nothing terribly significant about that, but let's repeat this. Let's add some more nines. Okay, some bigger numbers, because remember, we're approaching infinity, so adding some more nines. All right, and it looks like the numbers starting to flatten out a little bit, or at least in a decimal sense we can kind of see where this is going. So let's add some more nines here. Okay, and hopefully some of you are looking at this and saying, hey, that number looks familiar. It is a decimal. It's not a nice rational decimal or anything like that, but this right here, this is the decimal approximation for the number e. Okay, the constant e. So what we see just from evaluating some of these large numbers is that this limit as x approaches infinity is actually equal to, e. Okay, now we can use some algebraic manipulation and some we'll use some variable substitution and some limit properties to evaluate some limits that are similar to this form. Okay, you can see that these look related, and that's going to help us evaluate limits that are close to this without having to actually go through this process. So for this next one, so b is just some real number here. B is a constant. We have the limit as x approaches infinity of the quantity 1 plus 1 over x. Now it's raised to the b times x. So the first thing I'm going to do is use properties of exponents to split this and write this as the quantity, forgot the limit as x approaches infinity of the quantity 1 plus 1 over x raised to the x, and then that whole thing is raised to the b. Because if you remember, a power raised to a power, we multiply, so splitting them apart, I've got one raised to the other. Okay, now, I can also use a property of limit that says if I am taking the limit of a composition of functions, I can actually move the limit to the inside and evaluate that first. So this then is equal to the limit as x approaches infinity of 1 plus 1 over x to the x, and then move that b to the outside. Now, from this theorem over here, we know that this entire inside here is equal to e, so we end up with e to the b. Okay, now what this allows us to do is if we see the limit as x approaches infinity of 1 plus 1 over x raised to the, let's say, 5x, well, we don't have to go through this in-between property, these in-between properties with algebra and limits, and we can just say, hey, we know that's going to be e to the 5th. Okay? All right, this next one is similar. Here, the constant c is on the inside of the function. So for this one, I'm going to use u substitution because we're pretty familiar with that. So I'm going to say, let's let u equal x over c. Okay, u is going to be equal to x over c. Then x will be equal to c times u, and then now I'm going to put everything here in terms of the variable u. So I'm going to have the limit, and instead of having x approaching infinity, I need to know what u is approaching. Well, if x is approaching infinity, and I take infinity and divide it by some constant, I still approach infinity. So I can say that u is approaching infinity here. And then on the inside, I have 1 plus c divided by, and then x is equal to c times u. So those c's will actually cancel out, and then I just have a 1 left in the numerator. And then raised to the x, which again is c times u. Okay, from here, I can use this property, or this limit theorem over here. The same way I did here, we can say, well, let's just move that c to the outside. We end up with the limit as u approaches infinity of 1 plus 1 over u raised to the u, and then that whole thing is raised to the c, which according to this theorem right here is going to be e to the c. So if you have a constant on the inside in the numerator over the x, and we have the limit as x approaches infinity of this form, then we can just skip straight to the end here and have it and evaluate it as e to the c. Okay, this one right here, we can go through the algebra if you want to, but really this is a combination of this property here, and we end up with e to the b times c. Okay, so we can take this constant, and both of them become exponents of e. All right, now the reason I'm going through this is if you run into one of these limits, you don't have to use these limit properties to evaluate. You can just say, hey, I know what this is going to be based on this theorem. All right. Okay, this one's a little bit different. Instead of having x approaching infinity, we have x approaching 0. And then on the inside, instead of 1 over x, we have an x. And then we have a 1 over x there. So again, I'm going to use variable substitution. And I'm going to say, whoops, move that word down. Okay, I'm going to say let u equal 1 over x. Okay, or the reciprocal of x. So then this becomes, and I'll come down here a little bit, this becomes the limit. So if x is approaching 0, the reciprocal of 0 is infinity. So we can say that u is approaching infinity, and then this becomes 1 plus, and x is equal to 1 over u, okay, if I rearrange that. So I get 1 over u here, raised to that's exactly equal to u, and then this exactly matches the first form, so again, we end up with the exponential e. Okay? All right, so take a second to pause this and try and evaluate these three limits, and then resume and see if you get the same thing I do. Okay, for this one, I'm using that second theorem that we talked about, this one right here, and I can see that my b value is a 2, so this is e squared. Okay, and again, I don't have to do the algebra to prove that because that's what the theorem is for. Okay, this one I am going to do a little bit of algebra for first because it doesn't quite match what we have, but I am going to split this into two fractions and write this as the limit as x approaches infinity of x over x, which is just 1, plus 3 over x, okay, raised to the x. And so now this is like this third theorem that tells me with a c value of 3, then this limit has a value of e cubed. Okay? And then for this last one, this looks very much like this one, but it's actually going to be a combination of this theorem and this theorem right here, because I can write this as the limit as x approaches 0 of 1 plus, negative x raised to the 1 over x, which again, you could do the variable substitution there if you want, but I end up with e to the negative first, which is 1 over e.